sheet metal design. So here we have sheet metal components. So what is sheet metal? The component which has uniform thickness and has special manufacturing processes. For that purpose, we are using sheet metal design here. Okay. So here we are doing the sheet metal design. So first of all, see here, I already said in the sheet metal design we are using for creating a special components which we are using to create the sheet metal components like in manufacturing. How the manufacturing will work for sheet metal components, the same kind of thing we will do in designs also, like creating engines also. Okay. For example, if I am creating a sheet metal component here, the first and foremost thing you have to create here is primary tab or primary ball or primary sheet, can say. So what we will do, we will take a single sheet. On that sheet only, by using the bending operations, we are creating the component. Okay. First of all, what we have to do means we have to go for the primary tab. So means see here where how in real time how the sheet metal components are manufactured. Means they will take a sheet, single sheet. They will take a sheet here. Okay, they will take. So only, but the thing difference is we can find here is in extrude we can give the different thicknesses, but here we can't able to keep the different thicknesses. It has a standard thicknesses only. Okay, and this component should not exceed the thickness of the component should not exceed 20 mm. Why? Because after the 20 mm we can't able to create the component. 20 mm is 0.9. That's not that much also actually. Usually different component has very less thickness. Why? Because bending operations we will do. So bending operations we will not able to make it the thickness is more. So if we do also means the object will get cracked. That's the reason bending operations will not perform here. So due to which what we have to do means we have to be careful while selecting the material thickness. Okay, it should be less than 20 mm only. That is also I think very big. 20 mm. Around 0.25. 7.58 mm. 10 mm. Yeah, like that we will take the component thicknesses. So first of all, what we have to do means, see, in KTR we have discussed that sheet metal parameters will create. Here defaultly, there we have to keep the sheet metal parameters compulsory, but here defaultly some values will be there. Defaultly in annex object. If you want to change that one means what you have to do, you have to go for menu, preferences, sheet metal. If you go here you can find the material thickness, bend radiuses, relief depth, relief width, and neutral factor. Neutral factor is also very important here, guys. Why? Because neutral factor, what it will do means, what is neutral factor means? Suppose, for example, if you are doing the bending operation now, so the center of the sheet to the deformation, how much we are getting while bending. The ratio of that one we can say as a neutral factor. So the material thickness I am giving like for example 0.12 inches and bend radius I am giving like 0.24. That is my sheet metal parameters. If you click OK, now see here whatever it will create automatically. Okay. For example, I am creating the base tab here by using the tab command. Here we have base. So first sheet we have to take how much size of sheet is required. You can take here for example I am selecting this curve For creating the sheet, I am creating a rectangular sheet here, like this. I am giving the parameters. Always remember, as we have to give here. This I am giving, like, for example, 5 mm, and this one I am giving some 3 mm, for example. Okay, now see here, this is my sheet, for example. Click on finish sketch. So see here, the thickness is automatically it has taken it. If you are trying to change the thickness, I am pressing 1, 2, 3, 4, 5, 6, 7, 8, and 10. Nothing is changing here. Okay, here to show the thickness variable, it is not all changing here. Why? Because we have given the thickness is like 0.12. So here default it will take the thickness. Suppose for example, if you want to give some other thickness other than this one, the value which is given in the sheet or the preferences, then just click on this. Here you can find the equal to symbol. Now if it is there, means you're not able to change the value. So if you want to change the value, just click on this equals to symbol, use local value. Then you can able to change here how much you require. I want 0.25. Okay, now it has become like 0.25. But usually what we will do, we will use here the global value. Whatever the sheet model preferences we have given, that value only we will take here. Then in which direction you want? Top side you want, bottom side you want. Wherever you want, you can give it. Like this. Okay, this is my first parameter. This is my first parameter. The first feature, like the first primary tab has been created there. On this tab only we will give. Okay, right now what you see, the tab has been created. On this tab only we have to assign the remaining features. Everything we have to do here only for the primary tab. The next thing what we have to do is, in tab only one more option is that is my secondary tab. Initially when I go for this command, now here it is showing me only the tab here. For example, gets separately. Sketch create separately. First of all, because we want to have it difficult. Yeah, 3 only I wrote here. Finish sketch. Go for prime. If you go for tab command, here it is initially it will show only one command, that is base here. Okay, why? Because right now initially we don't have anything. That's the reason it is first of all it will get only base only. So go for the base option, select this curve, click OK. Now after that one, whenever you are creating any feature, for example, so here you can find two options here, prime base and secondary. Okay. Now here you can find the secondary tab option. One more options will get here. Now what I am doing, one more sketch I am creating here, for example, on this face, click OK. And here I am creating some small tab here. Like that I am creating. This is usually what why we will create this kind of tabs here, means for giving the what we can say, locating the object. For locating purpose here we will create it. So for example, this card is going to fix on the other part. So in that case, where it will exactly place, means for that purpose we are giving this locating tab here. This value should be like around 0.25, this one 0.09, 0.05 for example, and this value has to be like 1. And I will take this part and I will make the pattern in this direction, reverse. Which distance I'm giving? 3. Okay. Like that I get this 2 tab finish sketch. Now see here I have this component here. So again I am going for tab. Here if I take this one like a secondary tab. So what happened here when we give this one as a secondary tab means select this one as well as this one. Invalid sketch content. Okay. Tab. This sketch is not taking. Okay. See here for example I will take only one only here. Tab. This sketch. Help. Go for tab. Select this sketch. Now see here what happens if you take the secondary here. What happens if you go for secondary means this component will be different and that component will be different. So like that. Okay, good, fine. Go for tab here. If I am selecting this curve, if you take the primary base curve, so what happened here? Again, it will ask you the direction where you want. I want, for example, the bottom side. If you click OK, so here what happened means here the both are base only. This one also base, this one also base. That's the reason what happened here. This will become like a separate component, and this will become like a separate component. If you make this one as a base component. For example, the same thing if you make with the secondary one, what happened? It will become like a single component. See here, it will become like a single one. See, completely it will become like a single one, like this. Now here also I require the tab. Go for tab, select this one. Okay, just hide your sketch. Like this. Now see here, this tabs has been created here by using this. So this is the difference you can find between primary and secondary tab. Primary tab, what happened means it will make like a separate body for you. It means it is like a base body for you. From there we are creating the features. If you go for the secondary tab, what it will do, it will directly attach to your primary tab and it will become like a single component. Okay, that is the difference between primary base component and base tab and secondary tab. The next option we can find here is flange. Okay, flanges we are using for creating the walls, like in AutoCAD and KTI we can find the command like walls. Now here we can say as a flanges here. Okay, now I want to create flanges on these 3 areas. See here, if you go for the company, some standards are there. So minimum flange length should be there. Minimum, what is the gap you have to keep for the flange from the hole. Everything will be there in your drawing. Okay, so those things we have to keep in like when you go for the company, then you can understand what are the things are there. Okay, what are the standard values are there, everything we can find there. Okay, now what I'm doing, I'm going for the base plan. Here's the first plan. Where here what we have to do means we have to select the edge. Okay, here first of all it is asking you to select the edge where you want to create the plan. For example, I am selecting this edge for creating the plan like this. Okay, so see here we have so many parameters are there. One by one we will check all the parameters here. First of all, I will change the view of that object to right side view. Now see here my primary tab is still here. This is my primary tab. So the edge of this primary tab is is attaching to the outside of the flange. Okay. First of all, we will check the length here. The length of the flange, how much you require. Here you can give the length of the flange. I am giving the length of the flange to be like 0.9 9. Give 1 only. It's better. Okay, that is my primary flange. So I have given the flange length here, that is 1 mm. Where you want downside, you want upside. So based on the requirement, you can place the flange. I want upside, for example. Okay. The next thing is match faces. You want to match any faces. Like for example, if you are giving the length value, instead of giving the length value, you can select any reference face. So what happens? This flange will get attached to the face. Okay. Now see here guys, the first thing is specifying the flange length. Now angles also we can able to specify. Right now here it's getting exactly 90 degrees flange here. I don't want 90 degrees, I want 70 degrees flange. Okay, I want 70 degrees flange. I want for example 110 degrees flange. Like that. So like that we can able to specify the flanges here how we require. Okay, so like that we can able to create the flange by giving the angles and by giving the flange length. Okay, the next thing is I am making this flange see only now to show these options. Like see here the length reference. Right now whatever the length you are specifying, see here I have given the length of the flange as 1 mm, 1 inch. So what it will do, it will calculate from the inner face of the primary tab or base tab. Now see here the length of the flange is measuring from this top edge. Why? Because I have given the length reference as inside. If you give length reference as outside, what it will do? It will make from the bottom side here. Okay, it will measure the length of the flange from the bottom side. That is the next option. If you go for the wave option, means it will take from this side, like where the bend is ending. This one we can see the fillet area we are seeing here. Here we can't say this one as a fillet, this one we can say as a bend. Remember this one. If we are seeing this thing in part modeling, we say as a blend or we can say fillets. But here this one we can say as a bend. So web if we take means it will measure the length of the flange from the end of this bend. Okay, like that. So how much length you want, you can able to specify to your flange. The next thing is here inset. Inset is the sense, see here right now the outside face of the flange is meeting with the edge of your flange base tab. The base tab and the outside face of the flange is meeting here. Why? Because we have given material inside, means material completely inside of that edge. If you go for material outside, what happened here? This edge will meet with the inner face of the flange. Okay. If you go for complete bend outside, means the complete bend will come outside of this edge, whatever you select for the flange. Okay. So that is the difference you can find between this material inside, material outside, and bend outside. So like that we can able to create this flange here. Okay, now the next one what we will do, we will check these options here. I am giving for inside and this one I am giving material inside only. Now the next thing what, okay, fine. Okay, now see here the next thing I am seeing here is width option. Okay, width option is there. So here I am saying full means whatever edge you select, if you choose the option full, whatever edge you are selecting for the complete edge, it will create the flange here. For example, if you don't want for the complete edge, I want for the limited edges, means you can go for the option here. If you want full, you can go for full. If you go for edge center, what happened here? From this center, it will how much you require on both sides. Both sides means from the center, whatever value you are specifying, it will assign equal parts on both sides. For example, it's 1.5. I want to change this one to, for example, 2. For example, now see here what happened here. It will increase the length on both sides. So whatever value is specifying, it will assign on both sides from the center of your edge. Okay, that is the edge center option. If you go for the option end want to measure this width value. I am selecting from, for example, this one. So what happened here, it will measure the length of the flange from this, width of the flange from that point, whatever point you are selecting. The next option we can find from end. So here what happened, the point whatever you are selecting, from that point how much gap you want to give to your flange. I have given from end 1.25. So the length from here, this point to here is 1.25, and from that 1.25 it is creating the width of 1.5. So like that we can able to choose the option from end also. The next option is from both ends. So here what happened, how much gap, here it is not asking me to specify the distance of this flange, it is asking me how much gap you want to leave for the flange from both ends. This end how much you are leaving, and from this end how much you are leaving. So like that, for example, I am giving this length like this and this one like this. So like that we can able to specify the width of your flange. Okay, like that. So I want like this, I am using this option only. Now see here, Bakri. The next option we can find here is offset. Okay. The next option is offset. See here, when you carefully see, for example, I am going here. Now, this outside edge is meeting with the inner face of the flange. If you want to give any offset value here, like from here to here, how much offset value you want, you can give here like that. We can able to give the offset value for your flange if you require. Sometimes we require this option also. Offsets we will make to match the faces. So for that reason, for example, why, because here every component, whenever we are creating, that component will go and fit to your assemblies, like other components will get and fit with that component. So for that purpose, we require this for butting purpose. Butting in the sense, for example, we are using sheet metal means compulsory we have to do welding procedures only. Other than welding, usually we will not do. Primarily, we will do weldings only. For welding, we have to do butting here. Means different components we have to join by using welding operations only. So in that case, that one we can say as a butting. Okay. So whenever we have to perform the butting operation, sometimes what happens, we will find some more gap between the parts. So in that case, by using this offset operations, we will do butting. By using this offset operation. Okay. Like that we are using offsets here for creating the part. The next thing is bend parameters. See here, bend radius we have given the values at 0.24, so automatically it has taken. Am I audible to you guys?
Yes, sir.
Yeah, now Now see here guys, the next thing is bend parameters. So what is bend parameters means the bend radius, how much you require. So this is also standard value will be there. Why? Because you already specified this value in our sheet metal preferences. So these neutral factor also be specified there only. So there is nothing to change here. Sometimes what happens is to pass the checking bit errors, we have to change this value based on our requirement. Sometimes change, but usually we will not change this value because material has some standard properties. So based on that properties only it will automatically take the bend radiuses and everything it will take automatically. Okay. The next one is relief. Relief also usually will not change. Just I will show you how it will work. Bend radius. Inside one, not outside. If you change this value by using local value 0.242, I am giving for example 0.5 for example, like that. So this is the bend rate. Just I am showing you, usually we will not change this value like that. In some cases only, usually very less cases we are using the manual value, but usually we will go for the standard value. Okay, this is neutral factor. The next thing is release. Here this release value also will not change usually. Why? Because if you change it will make a problem while making the sheet metal thing. The next thing is relief, bend relief here. So here we have two types of relief charges. Square relief means will make like this. If you go for round relief, it will make like this. So this value also based on your material property. They will based on the material property, it will automatically take this. Okay, that is your relief. Round you want or square you want. What type of relief you want based on the material, based on the material and based on the cutting areas, we will use this. That's it. So this is your flange command. This is your flange command. Understand, guys? And one more thing is there in the flange. Here it is showing one thing. Initially it is not showing, but right now it's showing the function section here. So section means right now here we have this flange here. If you don't want rectangle shape, any other shape if you want means you can do edit this section. So go for edit sketch here, it will enter here. Now what happened here, I don't want this line, I want arc here for example. Like that I want for example. Click on finish. So how that line is there, so like that only it will create the plan. So for that purpose we are using that edit sketch option. Understand guys this flange command?
Yes, sir.
Yes. Okay then. Now we will go for the next, that is counter flange. Usually this is not the standard one. The standard one, and because like that we can't able to do. Usually if we want that shape also means we will extend the size, we later will do cut down to remove that external. Now see here guys, the next command we can find here is counter flange. Counter flange of the same title only. Here also we can find secondary on base. Here what we have to do means we require some sketch here. What I will do, I will go for sketch on this particular page. On this page I want to sketch. Let me go here, click OK. What I will do, I will create one curvature shape here. So it is nothing is there. What kind of plan is required we can able to create. Okay, this should be a tangency here. This should be a tangency relation between this curve to this edge close. Okay. Now see here, like that we can able to create the counter flanges. Counter flange in the sense how the guide curve you are giving based on that guide curve only it will create the this is the counter flange guys. So based how you are creating the curve, so based on that curve only, it is like extrude command only, open extrude like. So we are when we do the extrude for the open profile now, how it will work the same title only, it will work like a counter flange also. Finite you want, symmetric you want, to end you want. These three options you can find here. So how you want? So finite you want means you have to give the distances here, how much you can find. If you go for symmetry, whatever value is specified, you will assign on both sides. If you go for so and it will come like this. Okay, if you go for chain option here, multiple edges you will not work for this. Some other option is there for that. Okay. Guys, just we have this meter option. I will check this option tomorrow. Actually, some just do practice here. In counter flange, in counter